Hello and good day. My name is Associate Professor T.S. Dr. Deva. I am from the Faculty of Engineering in University of Malaysia Pahang, and my contact number and email is as stated here. Our product is bio-hybrid engine coolant. The main idea of the coolant is achieved from bio-inspired materials to make this new radiator coolant. So the main novelty of this product is it has higher thermal conductivity enhancements by 25% and increases the heat transfer capacity by 20%. And it is very environmentally friendly. The higher thermal conductivity means it can remove heat in a very fast manner, and also it has higher heat transfer capacity as it can restore more heat into the system before removing it. So the places that we can use these coolants is for machining, for semiconductor application, for power plant cooling, and for automotive. We are using automotive as our main platform because engines are vastly available in the world and people are using it for cooling. Even the latest hybrid and electric vehicles also requires cooling systems, and as such the coolant will be feasible for all these systems. For internal combustion engines, wear in the piston and knocking occurs due to the amount of heat that is dispersed from the thermal energy. So we need to somehow reduce this by using a proper coolant in the system. The cooling systems for the internal combustion engine or any heat engines is due to the radiator, and the radiator itself has reached its limits for the modification, and it is actually consuming a lot of space and weight of the vehicle. So to decrease the size of the cooling system, we can modify the heat transfer of the coolant itself because it has poor thermal transport, and the modification will serve as a design improvement for the vehicle. So for the cooling systems, there are many research going on. Okay, so they have research to design the cooling system, but however, the poor coolants can be addressed by using nanofluids. So when you enhance the heat transfer, we have found that some particles like graphene and Eg produces enhancements, and also zinc also can produce enhancements. But by adding graphene, which is a biomaterial, and also cellulose nanostructure, it can increase the thermal heat transfer more. So these are the literature that we found for the nanofluid in the automotive systems. So the general outcome of the nanofluid is to select the nanosystems, the preparation of the nanofluid, and the stability of nanofluid has to be done. So with this, we can find out which is the best way to introduce nanofluid into the system. So we have found that the graphene, which is used in solar cells and also batteries and supercapacitor, is one of the great substance to increase the heat transfer. And as well, cellulose nanocritical, which is product from the biosynthesis of animals and bacteria, is also another high-end material for heat transfer increments. To produce cellulose, we can use from the wood flour. From the wood flour, it can be acid hydrolysis into the cellulose crystals. So both graphene and CNC properties can be used to be modified so that it has physical and morphology properties, hydrophilic properties, and also homogeneous distribution for the system so that you can modify this particle to the enhancements we require. So this is the PI that we have already submitted, and our patent agent is East Coast IP Management. So for the market potential, we have found out that the market size is ever increasing until now, and we have found a business plan, and we also identified the main competitors of our product. We are targeting our product is around 20 ringgit per bottle, and we have also signed up with Focus Applied Technologies to produce this product. So this is the experiment setup that we are using. So our experiment setup comes from a radiator itself. It's from a 1 liter Paradova Viva. So it has all the components of bulk temperature sensors until the pressure drop sensors. We have a DAQ to monitor and grab all the data. So this is the stability measurements for 1 month. Then we have done the spectrometer absorbance test to show that it is stable. We have also done the 4 thermal conductivity, thermal viscosity, specific heat, and the density experiments. And as compared to the ASHRAE standard, the EGW and the particles around 0.5 concentration is the best enhancements. We are getting a minimum enhancement of 7.02% to a maximum of 28.9. And viscosity improvement also shows vast improvements as the viscosity is reducing as we are using a 0.5 capability. This is good to reduce the pumping losses in the radiator pump. And density also reduces when you add the particles and the temperature is increasing. And as such, the specific heat also is increasing as compared to the X-ray. So when we look at the results itself, we are having a Reynolds number, Nusselt number, and heat transfer results. So when we plot all these results, we found out that the Nusselt number increases with the Reynolds number. This shows that the heat is distributed into the radiator fins. And when we look at the thermal camera images, we found that the green yellowish dots at the center of the radiator has more green color, and as such it can show that it can remove more heat from the system. For the corrosion test, we found that the 0.5 percentage has the lesser corrosive nature compared to other composition due to the lesser agglomeration which is occurring from the TEM analysis. As a conclusion, we can say that the dispersed CNC and graphene mixture into the new coolant produces thermal conductivity increase from 0.492 to 0.652, and we also reduced the viscosity, and we created a very good coolant with less corrosions. We found out the recommendation due to the nanosubstance use, the radiator sizing, the base fluid that we are comparing, and also the temperatures. These are the publications we have already done, and then we have get an impact factor of 6.35, which is published, and we have also some more papers that is coming soon. And these are the reference. These are our collaborators that we have already achieved, and with Malaysian company of Gagasan Global, BMW collaboration, and also Focus Applied Testing for testing our instruments. To say thank you, and hopefully our product can be used for a greater good and for the more improvement soon. Thank you very much.